Right, lecture 2 of 4, function and graph. Learning outcomes. At the end of the lesson, students should be able to sketch the graph of a function again, but now we are going to concentrate on piecewise and absolute values of linear functions. State the domain and range of a function. Okay, so let's look at the absolute value graph first. So the tips. Okay, so if you have f(x) equals to a modulus x, if your a is greater than 0, so the graph pointing upwards. That's not good, isn't it? So let's just highlight the shade. Okay, pointing upwards. So if your a is less than 0, it's pointing downwards. Pointing upwards, pointing downwards. That's what I mean. So steps to sketch modulus graph. To determine the maximum or the minimum point, find the x and y intercept, and then this will be the range. Okay, so if you look at the sample graph given, so if you have y equal to modulus of x minus c plus d, so we are going to look at the minimum or the maximum point. So the value for your x comes from here, so which is when x minus c equal to 0, we get x equal to c. So the minimum point will be CD. So this is your CD point. Okay, definitely if you look at your x here, this is positive, meaning greater than 0. So the graph pointing upwards. So domain will be real number as the graph goes on and on to the left and also to the right. And the range starts from here, from D upwards. So that's why you get the half open interval D infinity. Okay, similarly for the graph, the second graph, so you get the value of the maximum point from here, so you get x equal to c. So the maximum point here now will be CD. So that's your CD. Okay, since you have here negative, meaning the x is negative, to graph pointing downward. So domain will be real number, range will be from negative infinity up to D. So inclusive of D. Right, let's look at the example. Example 11. So A, sketch the graph of the functions and state the domain and range for each of the functions. So y equal to modulus x. So definitely your a is positive here. So behind here plus 0. So I would say the graph definitely something like this, pointing upward. So we have the minimum point. So minimum point going to be 0, 0. Right? So something like this. So this is your origin. So domain will be real number. So range definitely from 0 upwards. Right? So if you look here, the value of the y, it cannot be lower than 0. So meaning this is inclusive of 0 to infinity. Okay, similarly for B, so we have a negative outside here. So again, behind plus 0, so the maximum point will be 0, 0. So the graph will look something like this. So this is your 0. So it goes down and down, pointing downwards. Hence, the domain will be real number. So range will be from the smallest value, which is negative infinity, up to 0. Right, look at C and D. So here, inside the modulus, we have x plus 4. So behind, outside the modulus plus 0. So x plus 4, if you equate to 0, you get x equals to negative 4. So the x is positive, so meaning something like this. Okay, that's the clue. So we have the minimum point to be -4, 0. So this is your origin. So find your x -4. This is -4. So find the intercept when x is 0. So you get y equals to modulus 4, which is also 4. So the graph will look something like this. Okay, so domain will be real number, range, again from the smallest will be 0 to infinity. Right, for D, behind here plus 0 again. So here for x minus 1, 0, x equal to 1/4. So we have the minimum point to be 1/4, 0. So find your 1/4, 0 somewhere here. Okay, when x is 0, so you get y equal to modulus of -1, which is 1. So something like this. So this is your 1. Okay, and domain will be real number, range will be 0, infinity again. So y equal to negative of modulus x plus 2 minus 3. So let's find the intercept. So when x is 0, y equal to negative modulus 2 minus 3. So we have -5. So this is your -5. So find the minimum or the maximum point. So when you see here, we have negative in front. So meaning we have the indicator and indicated that the graph looks something like this. So we have a maximum point which is -2, -3. So find -2, -3 somewhere here. This is -2 and -3 here. So this is how the graph should look like. Okay, so let's do it nicely. So this is where it cuts the y-axis at y equal to -5. So this point is -2, -3. So domain equal to real number, -infinity to infinity. So range equal to from -infinity up to here, which is the value will be -3. So this is -3. So hence the range will be from -infinity to -3. So for F, we have similar type of graph. So we also have negative in front. So meaning the graph will also looks like this. So we have the maximum point to be when 1 minus 3x equal to 0. We have the x to be 1/3, 1/3, 2. So find the point 1/3, 2 somewhere here. So this is your point 1/3, 2. So find the y-intercept. So when x is 0, so y equal to negative modulus 1 plus 2. So we have 1. So it cuts at 1. So this is how the graph looks like. So this is your origin. So hence the domain equal to real number, -infinity to infinity, and the range will be from -infinity up to the maximum value here, which is 2 inclusive. Piecewise function. So a function defined by multiple sub-functions, okay, applying to a certain interval. So we have more than one functions to sketch. Right, so let's look at the example here. So the first example, let's say if you have fx equal to x, that is when x less than 1, x plus 1 when x equal to 1, and negative x plus 1 when x greater than 1. So we are going to focus on the interval given. So there are 3 sections Before 1, at 1, after 1. So before 1, that will be the graph of x, meaning fx equal to x. So that's the line. So if you have y equal to fx, so meaning now y equal to x before 1. So this is 1. This is where we have x equal to 1. So let me write it nicely. So this is when x equal to 1. So before 1, so this is the graph. It passes through the origin. At 1, so the function will be x plus 1. So you substitute 1 inside this function. So you get 2. So at 1 here, you get 2 here. Okay. Then when x is greater than 1, so the graph will be this. That's what you mean by piecewise function. So the domain definitely referring to this. So it covers everything, so that will be real number. As for the range, so you have to look at piece by piece. So starting from below, negative infinity, it covers here, isn't it? Or from here, if you look at the right side, the right greater than 1, so it covers from here up to here, but then it stops. But covers, this graph covers here. And then it stops here. And then only this part. So that's why we have from negative infinity up to 1 here. There you go. But this is empty circle. So that's why it's open interval. And then you have to union at 2. And then here. Here only. So you have to union the element, the value of 2. So that's how you look at the range. Right, the next example, if you have fx equal to x squared, that's when x less than equal to 1. Between 1 and 3, you have the second function, x plus 1. When x is greater than 3, you have the third function, set of x minus 3, or square root of x minus 3 plus 1. Okay, so you have to focus on the values of the range given. So less than 1. So we have the quadratic curve. So there you go, the quadratic curve. And then between 1 and 3, we have the linear curve when x plus 1, when x is 1. So when x is 1, it becomes 2. So this is 2 actually. Okay. And when x is 3, it becomes 4. So this is actually 4. And then when x is greater than 3, so if you substitute 3 inside here, 3 minus 3 is 0, so it starts from 1. So this is actually 1. Okay. So when x, so there you go. So this is the graph of square root of x minus 3 plus 1. So plus 1. Okay, so this is the curve of the linear graph. So domain, definitely referring to this. Okay, which is, if you look at the symbol, you have to be very careful. So at 1, you have the equal there. But as for 3, 3 doesn't have any equal sign there. So that's why you will get negative infinity to 3, and then you have to union 3 to infinity. Okay, alternatively, you can write it to be something like this, meaning real number except 3. This is also accepted. Right? Okay, as for range, again, range. So let me change the color. So starts from here, from the origin. So this is O, the origin. Oh, sorry, the origin. From the origin, it covers up to infinity. So the range will be, okay, half open, 0, infinity. Example 12. Sketch the graph of the functions and state the domain and range for each of the functions. So a, fx equal to negative x squared, and then 2x. So you have the sections here given. So you need to sketch two graphs. One is y equal to negative x squared when your x is less than equal to 3. One more when y equals to 2x. That is when your x is greater than 3. So that's how we should look at it. So first, find your 3. So this is your 3. Your line y equal to 3. X equal to 3. Not y equals to 3. Pardon me. Okay. When x is less than 3. So when x equal to 3. When x equal to 3. The first function. So you have the equal sign there. This is where you get the equal sign. So you need to substitute into this equation. So when y equal to negative of 3 squared. So you get negative 9. Okay, so remember this is negative. So it is set curve. Okay, so when x equal to 3, if you substitute inside this, when y equal to 2 times 3, so you get 6. Alright, so the graph on the left of 3 will be something like this. Oh, that is not nice. So let's make it better. Hold on. Okay, that's the graph. Something like this. Oops, not good. Make it good. Alright, so let's say this is your negative 3 and negative 9. Yeah, negative 9. So this is your 3. Then you have the equal sign, so make sure you have the shaded circle here. So this is your origin. When x is 3 for the second curve, y is 6. So somewhere here. So that is the gradient is positive. So hence, something like this. So this is the curve y equals to 2x. So this is y equal to negative x squared. So this is your origin. Alright, so domain. Domain will be this. So that is, you have the equal there. So that will be a real number. So if you can see here, so let me change the color. So it goes from left up to this, stops here, but it continues here to the right. So smoothly from left to right, we have all the values. But for range, okay, for range, let me change the color back to red. Okay. So from negative infinity, so from here up to here, up to 0, it stops. So we will get, so negative infinity up to 0. If 0 is inclusive. But you need to union. Union what? So this value just now we found it to be 6. But that is empty circle. So that will be union 6 to infinity. So that's your range. Right, B, you have fx equals to 3 when x is less than equal to negative 1. Between negative 1 and 4, you have y equal to x. Between x greater and for x greater than 4, you have the graph to be 4 minus x. So let's just split it. So y3, yx, y equal to 4 minus x. So there are 3 graphs. Okay, so this is when x is less than equal to negative 1. So this is when x in between negative 1 and 4. You have the equal depth at 4. Let's write it nicely. Okay, when x is greater than 4. So we need to look at the value of x when it is negative 4 and it is negative 1 and 4. Right, find your x negative 1. So somewhere here. So x negative 1. And then find 1, 2, 3, 4. Somewhere here. So this is when x equal to 4. Alright, before when x is less than equal to negative 1, so the value y equal to 3. So we've seen before. So somewhere here. This is 3. Right, so you have the equal sign. So that will be the shaded circle. Between negative 1 and 4, the graph is y equal to x. So you just need to substitute. Try to substitute with negative 1. So if x is negative 1, fx also negative 1. So here somewhere is negative 1 here. So you don't have any equal sign there. So that is the empty circle. And then when x is equals to 4, fx also 4. So that's 3. So 4 up a bit. Okay, something like this. You have the equal sign. So that is your 4. Whoops. Please use your ruler. So that's your 4. And then for the next graph, when x greater than 4, the curve will be, the equation is y equals to 4 minus x. So when you substitute 4 inside, y equals to 4 minus 4, it tends to be 0. So you don't have any equal. So that's empty circle. Alright, so where does it go? Upwards or downwards? So when x 0, fx 4. So the graph should be something like this, but we only want this part. So this one you need to delete it. So this is 3. Okay, that's your graph. Okay, so the domain will be referring to this. So be careful. So you have to look at it carefully from negative infinity to 1. So you have the equal. 4 also you have the equal. So that should be a real number. So what about the range? So range. So from below up to here, it covers these two. And then here, it covers for this part up to 4. So the range will be negative infinity up to 4. Include 4. Right? Y include 4. So this is the shaded circle. C, fx equal to negative x when x is less than equal to 2. And square root of x minus 3 when x is greater than 3. So find your x equal to 2 and x equal to 3. So make sure you use proper scale. Okay, so this is your x equal to 2, and then we have x equal to 3. Okay, so make sure you have when x equals to 2, fx equal to negative 2. So you have equal sign, so the shaded circle. And then when x greater than 3, so when you substitute 3 inside the square root, so you get 0. So you don't have any equal sign, so empty circle to the right. So domain equal to this, which is negative infinity to 2 union 3 to infinity. So range from here above. So we have this value negative 2. So from negative 2 to infinity. So D, y equal to 5, y equal to negative x, y equal to square root of x minus 5. So again, find your negative 1. So this is your negative 1, x negative 1. So and then x4. So this is when x4, x5. So this is x4, x5. So when x is less than equal to negative 1, so fx is 5. So here, so you have equal sign. So that's your 5. And then fx y equal to negative x. So when x is negative 1, it becomes 1. When x 4, it becomes negative 4. So it passes through the origin. Okay, so this is 1. So make sure you use ruler. Sorry. So this is 1. Okay, let's do it again. Okay, so at negative 1 should be empty circle. At 4, it's shaded circle. And then when x greater than 5, the curve is square root of x minus 5. So empty circle to the right. So this should be dotted lines. Okay, alright then. So domain will be referring to this. So negative infinity to negative 1. Okay, from here, continue with this up to 4. So up to 4. So shaded circle. So that will be half open interval union from 5 to infinity. Range will be from 4. So this is the least value of y that you can get. So that will be negative 4. Negative 4. Not 4. Negative 4. Up till, goes on and on to infinity. Example 13, write the function fx equal to modulus of 1 minus 5x plus 5x as a piecewise function. Hence, sketch the graph. Write down its domain and range. So you need to define modulus of 1 minus 5x. So by definition, it becomes 1 positive 1 minus 5x. That is when if 1 minus 5x greater equal to 0, negative of 1 minus 5x, that is when if 1 minus 5x less than 0. So now write it further, solve it further. So we get this is if x less than equal to 1 over 5, this will be 5x. So you multiply the negative inside, 5x minus 1. So if x is greater than 1 over 5. So since we have the function to be fx equal to modulus 1 minus 5x plus 5x. Okay. So if I were to use the graph or a table, or if I don't use table also can. So we need to split the function into 2. So meaning 1 is when it is positive, meaning 1 minus 5x. So plus 5x, that is when x is less than or equal to 1 over 5. One more, negative, 5x minus 1 plus 5x. That is when x is greater than 1 over 5. So simplify further. So you have the fx to be 1 when x is less than or equal to 1 over 5. 10x minus 1 when x is greater than 1 over 5. So now we have the piecewise function ready. So next we need to sketch. So this is your x-axis, y-axis, and the origin. So you need to identify where is your x equal to 1 over 5. So let's say somewhere here. So make sure you use your ruler. Okay. So you write it nicely. So before 1 over 5, everything is 1. So draw the line. This is 1. So you have the equal sign there. So this is 1. And then after 1 over 5, the curve will be 10x minus 1. So if I were to substitute 1 over 5 inside here, so 10 times when x is 1 over 5, you want to see whether the two graphs connected or not. So 10 times 1 over 5 minus 1, we get 1. So it does connected. So you can see that the gradient is positive. This is positive gradient. So we know that it is slanting to the right. So the graph should look something like this. When x0, we need to see when x0 fx is negative 1. So this is negative 1. So will be something like this. So we only want the right side of 1 over 5. Okay, that's the graph. So what is the domain? So domain of f will be real number. So range of f will be, so from here and above. So that will be 1 to infinity. So include 1. So that will be half open. Okay, subtopic 5.4, exponential and logarithmic function. So we are going to do this subtopic first because we are doing all the graphs. Okay, so students should be able to state the domain and range of an exponential and logarithmic function. So let's look at the introductions for exponential function. So general form of an exponential function is fx equals to a power of x plus k, where x elements of real number and a should be greater than 1. Okay, y equal to k, known as the horizontal asymptote. So later on, we'll use HA. So steps to sketch exponential graph: determine the horizontal asymptote, find the y-intercept when x equal to 0, and the correct shape. Okay, so let's look at the graphs given here. So if you have fx equals to a power of x plus k, again, you have the value k at the back here, so that should be your horizontal asymptote, y equal to k. So this point here, the outer point, this refers to the values of the signs of your x and your y. So x here positive, fx here positive. So this point here positive, positive. Right? So and then this point here, it goes near and nearer to the asymptote, but it will never cut the asymptote. Please remember that. Right? So similarly here, if you look at this, so your x here, the sign is negative. Your fx here, the sign is positive. So on the second quadrant, your x is negative. Your values of your y is positive. Okay, the uppermost, the outer point, I would say that. Again, so this side goes nearer and nearer to the asymptote, but we never touch the asymptote. Okay, so look at the next two graphs, same thing. See the outer point. Okay, if you look here, your x is positive, but this negative actually refers to the fx. So you can bring this is for the horizontal asymptote. So this is actually fx equal to negative of a power of x. So that is negative fx equal to a power of x. So this is what I mean by the x is positive but the fx is negative. So here the value for the x ordinate will be positive, value of the y ordinate is negative. Okay, and the next one, if you look here, similarly x is negative, so you have the negative here, so this negative belongs to the fx. So the outer point, that will be negative, negative. Okay, use this theory and everything will be easy. So, and then if you look at the domain, so domain for exponential function, all will be real number. For every graph here, you can see that the domain is real number, right? And the range, you look at the values of the y's. Okay, so definitely we'll start with the horizontal asymptote and above for this case, right? Right? Okay, it goes outwards and upwards. Okay, similarly, so you have here from here to here. So that's why you get from k to infinity, right? That looks awful, so let's do it again. Something like this. Looks awful again, isn't it? So, okay. And then for the next graph here, so again, the range will be from k to infinity. For the next two graphs, we will start with the smallest value for negative infinity up to k. And this is also from negative infinity up to k. So that will be the range. Right. Let's look at example 14. Sketch the graph of the following. Okay, fx equals to 2 power of x plus 1. Okay, so again, so 1 here will be the horizontal asymptote, which is y equal to 1. So we find that one first. So this is the line y equal to 1. And then again, as I told you just now, so the x here positive, the fx here positive. Okay, so when x is 0, fx will be 2 power 0 plus 1. So that will be 2. So it cuts at 2. Okay, using this, so we have the the outer point, positive, positive. So somewhere here, and then the end here would goes nearer and nearer to the horizontal asymptote. So this is your graph. So domain of f will be real number, range of f will be 1, infinity, open interval. Okay, look at B. Same thing, you have the horizontal asymptote there, which is y equal to 1. When x is 0, so you get fx equal to 3, power of 0 plus 1, again you get 2. Okay, and then the point plus plus, this is positive, this is also positive. Okay, find your asymptote, whatever it is, you have to draw your asymptote first, which is here y equal to 1. So get the value of 2 here, so again, you get the same shape. Do it nicely. Okay, this is your graph. So this is 2. So again, domain will be real number. So range will be 1, infinity. Okay, C. You have plus 2 here. So this is your horizontal asymptote, y equal to 2. So you look at this value, your x is negative, this is positive. So this is negative, positive. Remember? So what is your intercepts? So this is, let's say, y equal to 2. Oh, that's not nice, isn't it? So draw it carefully. Oh, please use your ruler. Okay, do it again. Okay, let's say this is y equal to 2. So when x is 0, so substitute, you get fx equals to e, 0 plus 2, so you get 3. Okay, so this is 2, 1, 2, 3. So remember, negative, positive in the second quadrant. So the graph will be something like this. So this is your 2. No, this is your 3. Okay, so this is your point, negative, positive. So domain of f will be real number, range of f will be from 2 to infinity. Okay, can you follow? So what about this? So this is your horizontal asymptote. So y equal to 5. Find y equal to 5. Make sure you label the origin. Okay, when x is 0, so fx will be e0 plus 5. e0 is 1, so you get 6. So again, negative, positive. Okay, you will get similar shape. Okay, this is your 6. Right, domain of f will be real number, range of f will be 5 infinity. Okay, next, e and f. So you look at negative 1 here. So this is your horizontal asymptote, y equals to negative 1. So if you look here, you have x negative. So here this negative, I told you it belongs to fx. So we have negative, negative. So the asymptote y equals to negative 1. So this is y equals to negative 1. When x is 0, so substitute into the function fx equals to negative 2, e0 minus 1. So e0, exponent 0 is 1, so we get negative 3. So find your negative 3. This is your negative 3. So negative, negative, that is in the third quadrant, somewhere here. Alright, so the curve looks like this. So this is negative 3. Can you follow? Right, this is 0. So domain of f will be real number. Range of f will be negative infinity to negative 1. Okay, f. This is plus 2. So horizontal asymptote y equals to 2. So this is your y equal to 2. So your x is positive. Here negative belongs to y, so negative. Positive, negative, that is in the fourth quadrant. Here, positive, negative. And then when x is 0, so substitute into the function to get the intercepts. So you get negative e0 plus 2, so you get 1. Okay, this is your 1. So the graph will look something like this. Okay, so this is your 1. This is your 0. So domain of f will be negative infinity, infinity. This is the alternative to whether you write a negative infinity to infinity or you can just write real number. And then range of f will be, so negative infinity up to 2. Open. Make sure this is the open interval. This is open interval, the curve, because you can never touch the asymptote. Logarithmic functions. So a logarithmic function is of the form fx equal to log of x minus k, base a, where x is greater than k and a greater than 0. So x equal to k is known as the vertical asymptote. Steps to sketch logarithmic graph: determine the domain, find the vertical asymptote, find the x-intercept when y is 0, and then the correct shape. Alright, fx equals to log of x minus k. So where do we start with? So normally we will look at inside the log, so the x minus k must be greater than 0. Cannot be equal to 0. So here you get x greater than k. So this is actually your domain. So you know your domain already directly. So which is k infinity. Alright, so knowing that your domain is k infinity, meaning x equal to k, x equal to k here is your vertical asymptote. So meaning you can state that x minus k equal to 0, x equal to k, that will be your vertical asymptote. Alright, so to get the x-intercept, that is when your fx, when fx is 0, so you will get your x value. Okay, so from the graph you can see that the domain will be from k, so this is the graph, it goes to the right, and the range will be a real number. It goes towards infinity and it also goes towards negative infinity. Right, if you look at the characteristics of this graph, okay, to make sure that you are on the right track, so you can see that x here is positive, the fx here also positive. So the outer point of the graph should be positive, positive. Okay, so similarly, if you look at this graph, again, if you look at inside the log here, so you will get x minus k to be greater than 0, so x greater than k. So again, this is your domain, meaning k infinity. So your vertical asymptote will be x equal to k, right? So if you look at your x is positive, this negative referring to the y. So the outer direction will be the positive negative. That is in the fourth quadrant. Again, to get your x value, this is when fx equal to 0, you will get the value for your x here. Alright, so that's how you do it. So again, the domain will be k infinity and the range will be real number. Similarly for the next two graphs, so again, inside the log, so k minus x must be greater than 0, so you get x less than k. So this is the domain, the less than k, so negative infinity to k. So here you are. And then your vertical asymptote, still you will get k minus x, let's say, equals to 0, so you get x equal to k. So again, that is your vertical asymptote. Then you look at the sign of the x. So here x is negative, and then here it's positive. So the point will be negative, positive. So this is the point where we have negative, positive. Alright, so you have the x-intercept and the y-intercept. So when x is 0, you will get fx to be log k base a. So that is the value for your fx. So this is actually log of k base a. Similarly, to get your x-intercept, you get to get the fx equal to 0, and then you can get your x. Alright, so the next curve, the next graph, again, k minus x greater than 0, so x less than k again. So the domain will be negative infinity k, right? So here x negative, you look at this, x negative, this negative belong to the fx here. So meaning you have negative, negative. This is where you get negative, negative. Okay, so again, you get the intercept. When x is 0, you get the value for your fx. Alright, so when fx is 0, so you get the value for your x. So the domain We found it just now, and the range will be real number. So all in all, for logarithmic function, the range would always be real number. That is the main character. Example 15. Sketch the graph of the following function. So you have here fx equals to log of x minus 1. So again, we will start with x minus 1 greater than 0. So x greater than 1. So I told you already, so that is the domain. So 1, infinity. Alright. So for vertical asymptote, so we have x minus 1 equal to 0, x equal to 1. So find your x equal to 1. So this is your x equal to 1. This is your origin. So next, I told you the step will be look at your x and your fx. Both are positive. Right? So that will be positive, positive. So where is positive, positive? Somewhere here. So this is your positive, positive. As a guide. Okay, and then we need to get the x-intercept. So that is when fx equal to 0. So we will have log, let me write it nicely. So log of x minus 1 equal to 0. So the base is not stated there. So that should be of base 10. So x minus 1 equal to 10 for a 0. Change to index form. So you have x minus 1 equal to 1, x equal to 2. So we have 2 here. Alright, so then the graph would be something like this. So this is your positive, positive. So this is your 2. So we found the domain already. This is your domain. So the range will be real number. Done. Okay. Look at B, you have fx equals to ln of 2x minus 6. So this ln is actually log of 2x minus 6 base e. Make sure you know this. So again, we would use 2x minus 6 greater than 0. So you have x, 2x greater than 6, so x greater than 3. So domain of f will be 3 infinity. Just write it out. Then for the vertical asymptote, so vertical asymptote 2x minus 6 equal to 0. So we end up with x equal to 3. So find your x equal to 3. This is x equal to 3. So this is your origin. Okay, next. You look at the x again. So x here is positive. Alright, so this is positive, this is also positive. So somewhere here, the first quadrant. So we need the x-intercept. So when fx 0, so meaning ln or precisely log of 2x minus 6 equal to 0, that is base e. So 2x minus minus 6, change the index form, so e0, so 2x minus 6 equal to 1, 2x equal to 7, x equal to 7 over 2. So somewhere here, right? So then we can connect the intercept with the graph. Right? So this is your 7 over 2. This is where we have the positive, positive. Okay, so domain, we found the domain already earlier. This is your domain. And then your range will always be real number. Okay. Next, C. Okay, let's move on. So you look at C. We have another 4 questions here. So you look at C. So inside the log. So again, this is ln. So this is log base E. Okay, 3 minus x. So 3 minus x must be greater than 0, x less than 3. So the domain will be negative infinity 3. So for vertical asymptote, so we get 3 minus x equal to 0, x equal to 3. So find your x equal to 3. So there you go. So that's your origin. And then if you look at your function given, so your x is negative here. So this is positive. So this is positive. So we have negative, positive. Where is that? That should be in the second quadrant. So somewhere here. So we might get the x-intercept and the y-intercept. So let's see when x is 0. So substitute into the function. So we have fx equal to ln 3. Right? So we have ln 3 somewhere here. So this is ln 3. So let's say our x-intercept or fx equal to 0. So that will be ln of 3 minus x equal to 0. Don't forget this is of base e. So 3 minus x equals to e naught. So 3 minus x equal to 1. So x equal to 2. So there you go. 1, 2. So let's connect all the dots, all the points. So it will be something like this. Oh, looks awkward, isn't it? So let's do it again. Okay, something like this. Right, so I'm going to, hold on. Okay, again. Yeah, something like that. So that's your ln 3. So this is 2. Okay. So domain, we found the domain already here. This is your domain. So range of f will be real number. So done with that. Let's look at D. So we have fx equal to negative of ln x minus 2. So x minus 2 greater than 0. So x greater than 2. So for vertical asymptote, x minus 2, 0. So x equal to 2. So find your x equal to 2. So this is your x equal to 2. So you look at the x here. This is positive. So this is negative. So positive, negative, somewhere here. Okay, so that's the asymptote. So we know that the graph cannot, the graph cannot cut the vertical asymptote. So the graph will be something like this. So it only has one intercept, which is the x-intercept. So let's find it. So when we have fx to be 0, so negative ln of x minus 2, 0. Okay, 0. So ln of x minus 2, 0. So x minus 2 e naught. So x minus 2, 1. So x 3. So this is your 3. Okay, this is the origin. Alright, so domain. So I choose to write the domain here instead of up there. So the domain will be to infinity. So range will be real number. Okay, next. E fx equals to negative of x plus 1. So again, x plus 1 greater than 0. So x greater than negative 1. Okay, for vertical asymptote. So x plus 1 equal to 0. X equal to negative 1. So this is your x equal to negative 1. So x, negative 1. Make sure you label. Okay, next. X greater than negative 1. So meaning, you look at the outer point of the graph. So this is x positive. Here should be negative. Positive, negative. Where is that? That is in the fourth quadrant. Somewhere here. So that's the asymptote. Right? So we need to get the intercept. So when x is 0. So when x is 0, so we get fx equal to negative ln 1, which is also 0. So now the graph would passes through the origin. So let's do it. Okay. Something like this. Alright, so domain of f greater than negative 1. So meaning negative 1 to infinity. So range of f will be real number. Next f, similarly, 1 minus x greater than 0. So x less than 1. So for vertical asymptote, 1 minus x equals to 0, x equal to 1. So this is your 1. X equal to 1. Right? Okay, next, you look at the x. Negative. Here also negative. So negative, negative. Somewhere here. Isn't it? Negative, negative. Okay, so find the intercept. When x is 0, so fx equal to negative ln 1. So that is also 0. So it passes through the origin again. Okay, so let's sketch a graph with something like this. Okay, so that's your origin. So domain. This is where you get the domain. So negative infinity to 1. Range will be real number. Right? Right, domain and range of a function by algebraic method. So domain, we are going to consider possible values of x for which the fx is defined, positive, negative values or 0, and then range the possible values of y with respect to the values of x in the domain. Right? So these are the tips for certain functions. So let's go through the table. So if you have a fraction as a function, so definitely the denominator cannot be equal to 0. Okay, definitely you will use this when you have a reciprocal function. So from here, you will get the domain already. Okay, if you have a square root function, so under the square root, the gx here will always be greater equal to 0. So that's where you get the domain, right? So for logarithmic, so we've done several just now. So the gx here must be greater than 0. There's no equal because log cannot be, log of a 0 is undefined. Okay, and then if we have polynomials, constant, linear, quadratic, and cubic functions, the domain normally will be real number except if you are given the range of x, okay, in the question. Okay, exponential, so the domain will always be real number. Example 16. State the domain and range for each of the functions. So fx equal to 2x plus 5. So this is a linear function. So linear function is a polynomial, so hence domain of f will be real number. So you can always also write it as negative infinity to infinity. So next we're going to let y equal to fx. So y equal to 2x plus 5. Rearrange, so get x equal to y minus 5 over 2. So for all x elements of the domain, okay, what are the possible values of your y here? So y also will be real number. So hence range of f will be real number. So negative infinity to infinity. So next will be b. Fx equal to x squared plus 6x plus 5. So this is quadratic. Okay, so we need to do completing the square. So fx equal to, so the fastest way will be bracket squared minus bracket squared. So you have plus 5 there, so plus 5 at the back there. So half of 6, here 6, half of 6 will be 3. So get x plus 3 here, so get 3 here. So simplify for the x plus 3 squared, minus 9 plus 5, so minus 4. So that's your fx. So if you look here, this is a positive curve, a positive graph. So it is a smile curve with minimum point. So minimum point will be negative 3, negative 4. So for all x elements of the domain, so definitely the values for your y will be, the minimum will be negative 4 and up to infinity. Right, next, we're going to let y equal to fx. So y equal to x plus 3 squared minus 4. So rearrange y plus 4 equal to x plus 3 squared. So we have x plus 3. Just interchange the place. Alright, so this square, bring it to the right side, becomes square root. But we need the plus minus sign in front. Alright, so we have x equal to plus minus square root of y plus 4 minus 3. So again, anything with square root, so under the square root will be y plus 4 should be greater equal to 0, y greater equal to negative 4. Hence, range of f will be negative 4 infinity. Part C, fx equal to 3 over x minus 1. So x cannot be equal to 1. So this will be your domain. So domain of f will be real number except 1. So for range, so we are going to let y equal to fx. So y equal to 3 over x minus 1. So x minus 1 equal to 3 over y. So get x equal to 3 over y plus 1. So again, the denominator cannot be equal to 0. So that's your range of f will be real number except 0. Okay, next let's look at D. So we have fx equal to square root of x minus 2. So under the square root, x minus 2 must be greater equal to 0. So x greater equal to 2. So that will be the domain of fx, 2 to infinity, half open. So next, for all x elements of the domain, what are the possible values of y? So if domain 2 to infinity, meaning your x will be 2, 3, 4, 5, etc. So x, 2, 3, up to infinity. So if x2, you substitute into the equation here. So you get y to be 0, 1. If you substitute 4, you get square root of 2, etc. So y will be elements of from 0 to infinity. So this is number 1. So next, we're going to let y equal to fx. So y equal to square root of x minus 2. So we are going to squaring both sides to eliminate the square root. Alright. So we have y squared equal to x minus 2. Rearrange x equal to y squared plus 2. So if you look at the right side here, this is y squared plus 2, which is a quadratic. So anything with quadratic, values of y must be real number. So we have one of it y elements of 0 infinity, and one more we have y elements of real number. So this contradicts both are contradict each other. So we're going to find the intersection between the two. So we're going to draw a number line 0. So we have here 0 to infinity, and then we have real number. So find the intersection part. So the answer will be the range, which is 0 to infinity.